Psychrometric processes. Through various psychrometric processes, air is to be conditioned. For conditioning air, we require to maintain temperature, humidity, and quality of the air. Temperature is maintained either by heating, sensible heating, or sensible cooling. Humidity by using humidifiers or dehumidifiers. And the quality of air is maintained with the help of addition of adiabatic mixing. Say for 20% of fresh air is added to the main streamline. 20% is removed before we send the air to the chillers, and other 20% of the fresh air is mixed adiabatically. Adiabatic, we call it as adiabatic mixing, and it can be achieved with the help of some psychrometric processes. Psychrometric processes: sensible heating, sensible cooling, heating and humidification, cooling and dehumidification, humidifying, dehumidifying, cooling and humidification, heating and dehumidification. So all these processes will help us to maintain air. Sensible cooling, sensible heating, only the dry bulb, increase in the dry bulb temperature is sensible heating. Sensible cooling is decrease in dry bulb temperature, dBT. And adiabatic mixing of two streams lead to change in the lot of factors, temperature, humidity, and purity. Of course, purity will increase, temperature will get disturbed, humidity will get disturbed, and to maintain it again we require air conditioners for humidification and for decreasing temperatures. Cooling with the dehumidification followed by reheating. Cooling with dehumidification followed by reheating. Nice. Dehumidification is done by cooling. Simply you just cool the atmospheric air in a room. We'll find the air will reaches dew point temperature, and at that temperature you will find the formation of dews, and that can be removed with the help of dehumidification. We call it as dehumidification. And to increase the temperature, dehumidification is done first. To increase the temperature we require reheating. So if air is to be cooled and dehumidified, it may be found that the process line joining the inlet and outlet conditions does not meet the saturation line. Example: in cooling air from 24 degrees Celsius dry bulb 45% saturation to 19% dry bulb 50% saturation. The process line shows this to be impossible in one step. That is the reason why first cooling is done, dehumidification will take place, then we can increase the temperature by heating. Humidity remains the same. Next process, heating with humidification and heating with humidification. Sensible heating decreases relative humidity, This can be eliminated by humidifying the heated air. This is accomplished by passing the air first through a heating section, process 1 to 2, and then through a humidifying section, process 2 to 3. The properties of air at state 3 depend on how the humidification is accomplished. Steam injection, adiabatic spray, so the heating excess or lower should be done accordingly in the heating section. So first, the properties of air at state 3 depend on how the humidification is accomplished. Steam injection, adiabatic spraying, so the heating should be done accordingly in the heating section. Heating with humidification. Sensible heating decreases RH, relative humidity. Sensible heating decreases relative humidity. This can be eliminated by humidifying the heated air. So we need to humidify. Of course, we are heating. Just we need to increase the relative humidity. For that we require humidification. This is accomplished by passing the air first through a heating section and then through a humidifying section. The properties of air at state 3 depend on how the humidification is accomplished. It can be done by using steam injection or adiabatic spraying. You can also spray. Take a chamber. In a chamber you can use some sprayers, water sprayers. Allow the air with some velocity from one to the other direction, and in one place it will heat, and in other chamber it will humidify. It will spray. By spraying, humidification takes place. So humidity in the form of small droplets, it will get added to the air. Now coming to the advantages. There are no supply, return or exhaust ducts. So with the help of this heating and humidification, you won't require return duct or exhaust ducts and supply ducts. Only simple, directly, only one way route like thing. Individual air conditioning systems are the most impact flexible and lower in initial cost than others, except portable air conditioning units. Building space is saved for mechanical rooms and duct shafts. So individual air conditioning systems, we don't require the mass production of conditioned air, which is to be supplied to all the rooms. So it is not required, because we have only in the independent rooms we have that setup. So we don't require separate maintenance or observation of the rooms, mechanical rooms where the conditioned air is produced. it is easier to match the requirements of an individual control zone, and they are quick to install. Because of no large setup, it's only a simple and easy setup, so it won't require much time for the installation or for setups. So they are quick to install, their maintenance is low, easy to operate. So like that, we have lot many advantages. Whereas coming to the disadvantages, temperature control is usually on off, resulting in space temperature swing. Air filters are limited to coarse or low efficiency filters. Air filters are limited to coarse or low efficiency filters. Local outdoor ventilation, air intake is often affected by wind speed and wind direction. Noise level is not suitable for critical applications because it is independent and we need to set up our mechanical setup within the independent room. That's why it creates a noise pollution. So noise level is not suitable for critical applications. More regular maintenance of coils and filters is required than packaged and central systems. So more care is to be taken for this. So that is the final disadvantage of individual systems. It is easy to score the subject, and it is very important subject for upcoming trends because everywhere the refrigeration is and air conditioning is required. It is must. For that purpose, it is very important and essential for learning this subject. Refrigeration is done only to maintain the temperature of atmosphere of a given space lower than atmospheric temperature. Suppose our ordinary refrigerated area, that space, the temperature of that space is less than the atmospheric temperature. It is only done because of the refrigerator. But to maintain humidity, to maintain purity of that room, we require air conditioning. So air conditioning includes maintenance of temperature, and second one, maintenance of humidity, third one, and quality. Third one is to maintain the quality of the air. Therefore, the refrigeration and air conditioning is an important subject to learn for upcoming future.